Hello, my name is Robert Hansen. I also go by RSnake. I run a consultancy out of Austin, Texas called Sec Theory. I also run Hackers and Slackers for those of you who know me from there. I felt like it was time to create a video about DNS rebinding. It's a little known exploit that has quite a bit of damage potential. And it's one of those things, I've seen a bunch of different stuff on it. It's always sort of like half the story, or it's really hard to explain, and I don't feel like there's enough resources. It's certainly not consolidated all in one place. So I felt like it was a good time to sit down and talk to you and try to explain it out. I work better in front of a whiteboard anyway, and try to explain some of the nuances of it, both how it works as well as some of the defenses and why it's not going anywhere. It'll be there for a long time. So let's start off with some ground rules, talk about how this would normally work in a good scenario. So let's say you're a typical consumer and you want to contact, www.mywebsite.com. Pretty simple, So you're over here, you're Mr. Smiley Face, and my website's over here on the internet, and somehow they got to figure out where each other are. If I need to know that you want to contact me, and you need to figure out where I am at, because mywebsite.com doesn't really mean anything unless you're talking about in DNS, where that's just a mapping to an IP address. So let's say it maps to 1.1.1.1. How do I figure out where that is? Well, there's a DNS server out there that's marked as authoritative for me. So that's DNS, that's www. So you need to go find this authoritative DNS server and get the request, ask the question, where is mywebsite.com, and I'll respond with this IP address of this host. So it's kind of a couple different connections. This is over UDP, and this is over TCP. Makes a TCP connection and says, through a handshake, and then starts sending the GET request or whatever. And we'll talk about that in a second because it'll become important. But basically, this is how DNS is supposed to work. Real simple, kind of a three-step program, assuming this hasn't been cached anywhere, or you don't have put it in your host file, or you're not using an upstream proxy that makes a DNS request for you. Let's keep it simple for now. No round-robin DNS or anything weird on my side. Just a nice, simple, one-to-one mapping for DNS. So let's take an example instead. Where I want to, instead of being a bad guy, where I want to do a good DNS change from one IP address to another. So I want to change it to be a 2.2.2.2 instead. Now, if you've ever gone through like a data center migration or moved your web server over somewhere and your network guys are saying, oh, there's still people are still caching it or whatever, and you're never quite sure what that means. Well, this is what it means. Your browser can cache it in one particular way, which is called DNS pinning. So when this DNS response comes back, it comes back with a time to live. Let's say like 1 hour, for instance. In that 1 hour, your browser is supposed to respect this time to live and not actually change, not make another DNS request for another hour, not change the mapping between the IP address and the host name for an hour. And that's mostly to reduce the amount of chatter on the internet. But it also has some security implications. So depending on what browser we're talking about, let's just talk about IE for a second. This browser can actually cache beyond the TTL, and that's called DNS pinning. So you might have it set for an hour, but it'll actually set it for an hour and a half, 30 minutes longer than whatever your time to live is. So if it's 1 second, it'll be 1 second plus 30 minutes, 30 seconds and 1 minute, or 30 minutes and 1 second rather. So, and the reason for that is they don't want you to quickly switch between places too much, whereas Firefox, for instance, and a lot of browsers just like it, will totally respect the RFC and just pay attention to the TTL. They won't focus on anything else. And so there's pros and cons in both. The security of DNS pinning is dubious at best, but we'll talk about that in a second too. So let's say instead of me so basically how this gets mapped over in IE is that there's one actually failover, which is if I actually end of life this IP address, actually turn it off, the web server just goes away because I have done my data center migration, my hour's up. I know that all the TTL should be respected and just end it in 1 hour. What will happen is the next person to connect who's using IE with DNS pinning will try to connect to 1.1.1.1, but won't be able to. So it'll automatically say, okay, well, I probably need to make another DNS request because my time to live is out of date, the server's no longer up. It's probably because there's some sort of thing going on under the hood. The internet has changed in some way. So I need to go make another DNS request, and then it actually will go to the other IP address. So DNS pinning actually isn't much of a security feature if you can shut that off. So if this guy has a firewall, for instance, and just says, you're not allowed to come in through here anymore, or the IP address just goes away or turns off or whatever, all those things sort of have the same effect, and basically allows for DNS pinning to rebind the DNS, so that's where the word rebinding comes from. It'll rebind DNS to this new IP address. So that's how it's supposed to work in a good world, where there are no bad guys. Okay, now let's talk about bad guys. So let's say, instead of it being mywebsite.com, let's say it's evil.com. And it's still pointing to 1.1.1.1. And you have another page on your internal network called wiki. Let's assume this wiki is, it's a proprietary, very, very important, super secure. Maybe it's got, trade secrets on it, or whatever, something on it, that's something that's very sensitive, and you wouldn't want some bad guy to know about. So, so behind this firewall and the switch, or whatever you got back here from a network perspective, it can connect both to the wiki and to you. So this user, you, can contact your wiki, but I, on the internet, because this firewall is here, cannot. So that's very typical. It's what most intranet websites look like. If you're in an office infrastructure, this is where maybe you've got I don't know, maybe your internal print servers and all kinds of stuff. Any web-enabled devices would live in here. So, so if I want to be able to read this wiki, so let's say I found out about it because of DNS enumeration problems. Let's say you've got you're sharing both internal and external DNS out into the world, or you leak that information somehow. You accidentally say it somewhere on your someone's curriculum vitae or something. I've found a lot of stuff that way. Or maybe you shoulder surf someone at a conference. Whatever. Let's just say you found out that they have this wiki page sitting out there. You as an attacker. Okay. I as the attacker. I figure it out, and I'm going to go try to figure out how to get in contact with it. You as a good guy, you can contact it, so you know about it clearly. But I only have reference to where it exists. So let's say I want you to contact it. What I will do is I will say, contact me on evil.com, right? So at some point I send you a phishing email, or there's a message board or something you've got access to and I know about, so I'll send you a link on the message board, say, oh, my new thing or whatever, and it'll be hidden, totally invisible to you. But instead of having a TTL of 1 hour when you make the DNS request, I make it 1 second. So it's very important. The smaller the window, the more effective this is going to be. And then in JavaScript space, I do an XML HTTP request and say, I connect back to me in 2 seconds. So just 1 second longer than the time to live, or 1.5 seconds or something, just slightly longer than that. Meanwhile, I firewall you off from contacting the same www server that you were contacting before. So you can no longer contact that. So regardless of whether you use Internet Explorer or Firefox, this method will work, because in IE it says, well, I can't pin DNS anymore because this firewall is down and the DNS TTL is up. So that will no longer work. So I must rebind. So instead of having you contact 2.2.2.2 like I did before, I'll have you contact 10.10.10.10 RFC 1918 internal address space, natted behind the firewall, non-routable from the Internet's perspective. And so it'll look the same. I mean, you'll be still sending the host header of evil.com, www.evil.com, but you'll be instead sending it to an internal IP address, to this guy over here, instead of out into the internet, because you've rebound DNS to point locally, internally to your company. And this could be localhost, it could be your own computer, it could be another server in here, it could be on some other completely different area of the company. If you have like private VPNs, it's whatever, just something behind your firewall, something that you can connect to that the bad guy would not be able to connect to. Otherwise, why wouldn't they just connect directly? So, so now they can actually, using this XHR, the XML HTTP request, they can actually read content from your internal wiki, actually pull content in. It sounds pretty bad, because it is. So there's a couple defenses here. You might notice right away, the host is wrong. It says evil.com. It should say wiki or whatever. But it doesn't really matter unless the wiki actually pays attention to that and does something about it, which most don't, unfortunately, unless they're using virtual hosts. So yeah, you could look at the host header, and if you know that the host is wrong, then ignore the request or send them somewhere else or whatever, or just have them reconnect to the real domain or whatever. And magically that will solve your problem. So that's one solution. Another is if you're using HTTPS, SSL, TLS, and normally it's wiki, so you have something in the browser, an SSL server, whatever, that knows that that's a valid location. But now it's evil.com. Well, you're going to get an SSL TLS mismatch error. So that's another great way to solve that problem. But that requires them to not click through. If they click through, it'll still work. So that's less of a good solution than just paying attention to host header. So host header is the #1 best solution. Unfortunately, that means you need to every web-based firewall and router and switch and IP telephone and printer and wiki and whatever, everything needs to be recoded to pay attention to this host header. So it's probably not going to happen anytime in the near future. So let's talk about a different class of attack using DNS rebinding called session fixation. So a lot of people have no idea what session fixation is. So let me talk about how people make connections, just basic web-enabled connections on the internet. So first thing you'll do is you'll type, or your browser will send get / to the base directory of evil.com or whatever, http, /1.1 new line character return host header of evil.com, and then we'll send stuff like the accept headers and things that so I will accept gzip deflate encoding and so on. So there's a bunch of other headers here, and then on the response it'll say 200 okay. Some other stuff. I'm going to be gzip encoding this or whatever. It'll also potentially send something like a set cookie with some cookie in it. And subsequent requests, you will send a cookie and whatever that same cookie is. So if I set a cookie in your browser, on subsequent requests, this cookie will get set. This cookie value will send that same value back to you. So who cares, right? I can set your cookie and you'll send me a cookie, BFD. But what if we're no longer talking about evil.com and now we're talking about goodguy.com? Goodguy.com is sitting out on the internet, just minding its own business. And I, as a bad guy, have access to goodguy.com and I can set cookies. But I can't set good guy cookies, I can only set my own cookies. But what if I have an access to some sort of account on goodguy.com? What if it, I can log in, what if it's free registration or something, I get access or I hack somebody else's account or something. I can log into the site and I'll set a cookie in my browser, which is client side, so I can go into my cookie directory and go rip out this cookie or use JavaScript or whatever and just pull out this cookie. And then on evil.com I can set this cookie because I'm a bad guy, I own my own domain, I can set my own cookie. But who cares? Again, it's on evil.com, it's not on goodguy.com. But if I can rebind, do this whole same thing over again, but instead of 1.1.1.1 pointing to me, I'm pointing to 3.3.3.3 over here up to goodguy.com. Assuming goodguy.com doesn't pay attention to this evil.com host header, assuming it's not using SSL, the other defense I talked about, it'll connect to goodguy.com, and goodguy.com will ignore the fact that all this stuff is messed up, but it'll see that the cookie value matches a valid credential in the system. So it'll actually allow that user to log into your account. But who cares? I mean, so what, I get them to log into my account. It's my account, I'm a bad guy, why don't I just use my own account for my own goods? Well, it makes less sense when you're talking about session fixation on the internet, but what if we're talking about on the intranet again? So, we're talking back, here's this wiki page again, and so, so I set this cookie for your internal wiki. How do I do that, and what does that even mean? So let's say you're running some like OpenCMS software, a blogging system that's open source that I can go pull it down or whatever. And let's say it's got a very weak credential, or something that I know I could brute force. Something like credential, colon 1, 2, 3, 4, 5, 6. So it's, it's what, 1 million different requests or something to get through all of that. But that's 1 million you could do in a day, or you could do distributed over many different people, slice and dice or whatever. So this would be the cookie value. So I can't set wiki.com cookies, but I can set evil.com cookies. So I rebind from 101.101 back to 10.10.10.10, and I set a cookie as credential equals 1, 2, 3, 4, 5, 6. Okay, well that doesn't work. Well, I'll try 1, 2, 3, 4, 5, 7, 8, 9, whatever, so on and on. And I can do this very rapidly and send lots of requests to this thing. So most people, this is why it's important, most people don't really log invalid credentials. What they log is invalid logins. So I can just burn through these and send just millions and millions of requests, and unless they've got some sort of anomaly detection sitting there, or someone's monitoring the logs and really watching them like a hawk or something, there's a really good chance they're not even going to notice this happening. So you can fairly easily break into internal websites using both a mixture of session fixation, because I'm not logging you into my account, I'm logging you into someone's account instead, you see what I'm saying? And a mix of brute force. So now you're talking about multiple different facets of the same attack that enable all kinds of different bad stuff. So that's pretty nasty, and there's lots of sub things you can do in there. And it should be noted that credentials like this are almost always vulnerable to birthday attacks. And if you don't know what I'm talking about, go type in birthday paradox into Wikipedia, and you'll get a great example of what that is. So let's talk about the last thing you can do here. Let's forget cookies for now, and let's talk about Google. So one thing that lots and lots of bad guys want to do is scrape Google. They want data from Google all day long. So they'll do it for spamming purposes, to find blogs that might allow them to do blog comment spam. There might be old ASP classic pages that are vulnerable to SQL injection, rather, like the SQL injection worm that went around there looking for .asp ID equals or something. Maybe there's old versions of open source PHP that might be vulnerable to PHP file include. So basically, you just take the entire Johnny iHack stuff, so you take this entire Google hacking database and throw it against Google, and you get a good idea of what I'm talking about. They want all that data, because that will enable them to hack into potentially millions and millions of different machines. So, but the problem is, if they just make that request directly, which they can do, there's no reason, there's nothing stopping them from doing that, Google will eventually start delivering a CAPTCHA. So it'll say, please type in this, 5-digit, obfuscated, character image. Type it in and prove that you're a human. So now the bad guy has to outsource that to, India or whatever, the cost about anywhere between $4 and $12, depending on what you read, per 1,000 CAPTCHAs. So it's just an incremental cost on top of what the bad guy has to do. It slows everything down. So what if, instead of evil.com going directly to Google, what if they got other people to do it on their behalf? So instead of rebinding them to 3.3.3.3 or internal address space or whatever, I have them rebind to Google. So Google is nice enough to, from a bad guy's perspective, not to care about host headers. So if I want you to connect to Google and I send the wrong host header because of DNS rebinding, they don't care. They'll let you do it as much as you want. So they may change that eventually, who knows, but for right now it just works like a charm. So instead of me contacting google.com directly, I'll have you connect to Google on my behalf, and you're sending the wrong host headers, which they don't care about, and you'll make a request on my behalf to go, let's say, pull down some SQL injection pages or something, potential SQL injection targets. And instead of me hacking those SQL injection targets directly, so hacked.com, some poor schmuck who gets hacked, I can contact them directly if I want, or I can rebind again through another iframe or something, and have you hack hacked.com on my behalf. So I can use DNS rebinding for basically a complete suite of a whole bunch of different types of attacks that might require both backwards and forwards communication, which is normally prohibited. So the same origin policy basically says that you're not allowed to make any cross-domain requests and read any data back. So unfortunately that's broken in like 100 different ways, but this is like one of the easiest ways to do this if you have this whole setup. So what this requires is at least one web server, probably 2 or more because you're going to want to log the data, a firewall or some way to shut the traffic off, a DNS server that you own, a host name or DNS or sub, you can use multiple subdomains, and a lot of traffic. If you own a porn site or something and you have like 1 million users, you could use all of them to attack on your behalf, for instance, or whatever. So it really is not that complicated attack. It's really just more, there's a lot of moving parts. This XHR thing I was talking about, XML HTTP request, there's another tool called Beef, capital E in the middle, written by Wade Alcorn, a little hard to find, but excellent tool for demonstrating the power of using XML HTTP requests to your advantage. It's not the most secure thing in the world. It's designed with insecurity in mind, but it's a good example of how this could be used. You can find it in the latest version of Backtrack. But this is pretty much the attack. And for this to work, it really just requires that the browsers do nothing other than support JavaScript and support the RFCs that DNS allows. So this attack is not going anywhere for a long time. I would be surprised if we see it disappear within the next 5 to 10 years. It's just the way the internet works, and unless everyone changes their host header, which is a great way to fix the problem, by the way, we're not going to see this problem go away anytime in the near future. So, change your host headers, or start respecting your host headers, rather. Use SSL if it's a secure website, and obviously inform your users that your SSL site is up to date and everything. And other than that, good luck. I hope this has been somewhat informative. Maybe I'll do this more often. But if you have any questions, send me an email. Thanks.